Have you ever thought about the flat Earth theory? Have you considered whether the Earth is spherical or flat, and pondered where all the information about the spherical Earth comes from if it were flat? Today, we want to delve into this topic, examining the scientific evidence to properly understand the matter. So if you're interested in this subject, stay with Green Podcast until the end of this video as we explore the intricacies of the flat Earth theory. Welcome to the Green Podcast channel. In this video, we'll be exploring the flat Earth theory and its challenges. We'll delve into key aspects of the flat Earth hypothesis, examining notable difficulties and unanswered questions it encounters when compared to the widely accepted spherical Earth model. Through concise analysis, our aim is to shed light on the scientific considerations and observable phenomena shaping our understanding of the Earth's form. Join us on this journey as we navigate the complexities of the flat Earth theory and its implications on our comprehension of the world we inhabit. Don't forget to subscribe for more intriguing content and hit that like button if you find this exploration fascinating. The flat Earth theory is the belief that the Earth is flat rather than spherical. This theory has been debunked by centuries of scientific evidence, but it persists among a small fringe group of individuals. The flat Earth concept suggests that the Earth is not a globe, but a flat, disc-shaped object. Proponents of this theory often reject established scientific principles such as gravity, satellite imagery, and the physics of celestial bodies. Historically, the idea of a flat Earth was more prevalent in ancient civilizations, but it was largely replaced by the understanding of a spherical Earth through observations and scientific advancements. In modern times, the resurgence of the flat Earth theory is often fueled by misinformation, misinterpretation of evidence, and distrust of scientific institutions. It's important to note that the overwhelming majority of scientific evidence supports the Earth's spherical shape, and the flat Earth theory lacks empirical support. The widely accepted model of the Earth as an oblate spheroid is based on a wealth of scientific observations and measurements from various fields, including astronomy, geophysics, and space exploration. It's important to note that the overwhelming majority of scientific evidence supports the spherical shape of the Earth, and the flat Earth theory lacks empirical support. However, for the sake of providing a comprehensive overview, it's worth mentioning that proponents of the flat Earth theory have put forth various claims as evidence. It's crucial to emphasize that these claims have been debunked and are not scientifically valid. 1. Flat horizon. Some argue that the horizon appears flat rather than curved, suggesting a flat Earth. However, this is a misinterpretation of perspective. The Earth is so large that its curvature is not easily noticeable at ground level. 2. Water's surface level. Flat earthers often claim that bodies of water, like oceans and seas, display a perfectly flat surface. However, gravity causes water to conform to the Earth's shape, and large bodies of water do exhibit curvature. 3. Flight paths. Some flat earthers question the flight paths of airplanes, suggesting that they would be different on a spherical Earth. In reality, flight paths are determined by factors such as wind patterns, air traffic regulations, and fuel efficiency. 4. Gravity as a hoax. Flat Earth proponents sometimes assert that gravity is a hoax and objects fall due to some other force. However, gravity has been extensively studied and observed, and its effects are consistent with a spherical Earth. 5. Lack of photos of a round Earth. Some argue that the absence of real photos of the entire Earth from space supports the flat Earth theory. In reality, there are numerous photos and observations from satellites and astronauts clearly depicting the Earth as a sphere. It's crucial to reiterate that these arguments have been thoroughly debunked through scientific evidence and observations. The flat Earth theory is not supported by the vast body of knowledge in astronomy, physics, and other relevant scientific disciplines. Comparing the flat Earth theory with other geological theories reveals significant disparities and highlights the numerous criticisms raised against the former. 1. Flat Earth versus spherical Earth. Geodesy. Flat Earth. Advocates of the flat Earth theory argue that the Earth is a flat, disc-shaped object. They reject the conventional understanding of a spherical Earth, citing perceived discrepancies in observations. Spherical Earth. Geodesy. The widely accepted geodetic model posits that the Earth is an oblate spheroid. This is supported by extensive evidence from geodetic measurements, satellite observations, and celestial phenomena. 2. Flat Earth versus plate tectonics, geophysics. Flat Earth. The flat Earth theory generally lacks a comprehensive explanation for geological phenomena, including the movement of tectonic plates, earthquakes, and volcanic activity. Plate tectonics, geophysics. Plate tectonics is a well-established geological theory explaining the Earth's dynamic behavior. It describes the movement of rigid plates on the Earth's surface, leading to various geological features and phenomena. 3. Flat Earth versus gravity, physics. Flat Earth. Some flat Earth proponents deny the existence of gravity or propose alternative explanations for objects falling. This challenges the fundamental physics underlying a spherical Earth. Gravity, physics. Gravity is a fundamental force that has been extensively studied and observed. Its effects, such as the shape of water bodies and the behavior of objects in free fall, align with a spherical Earth. 4. Flat Earth versus astronomy. Flat Earth. The flat Earth theory contradicts established astronomical principles, such as the Earth's shadow on the Moon during a lunar eclipse and the observable curvature of celestial bodies. Astronomy. Astronomy consistently supports a spherical Earth through observations of celestial phenomena, satellite imagery, and space exploration data. Criticisms of the flat Earth theory. 1. Lack of consistent explanations. The flat Earth theory lacks a cohesive and scientifically sound explanation for various natural phenomena, including gravity, satellite observations, and celestial mechanics. 2. Misinterpretation of observations. Advocates of the flat Earth theory often rely on misinterpretations of everyday observations, such as the appearance of the horizon or the perceived flatness of large bodies of water. 3. Disregard for established science. The flat Earth theory requires the rejection of well-established scientific principles across multiple disciplines, including physics, geophysics, and astronomy, without providing robust alternative explanations. 4. Inconsistencies in flight paths. Assertions about inconsistencies in flight paths on a spherical Earth are based on a misunderstanding of factors influencing air travel, such as wind patterns and navigational considerations. In summary, the flat Earth theory stands in stark contrast to established geological and scientific theories, and its foundational concepts are consistently debunked by empirical evidence and scientific principles. The flat Earth theory, if taken seriously, would have profound and detrimental effects on the life of animals, plants, and ecosystems. 1. Distorted ecological understanding. Flat Earth. Perspective. Embracing a flat Earth perspective would lead to a distorted understanding of ecosystems, biodiversity, and ecological processes. This could hinder conservation efforts and the development of effective environmental policies. Reality. Modern ecology relies on a spherical Earth model to understand climate patterns, ocean currents, and the distribution of species. Rejecting this foundational concept would impede ecological research and conservation strategies. Disruption of migration patterns. Flat Earth perspective. Animals often navigate using celestial cues, including the perceived rotation of the sky. A flat Earth model could disrupt their migration patterns, as celestial navigation would be inconsistent with a flat, non-rotating sky. Reality. The understanding of migration patterns, especially for birds and marine species, is based on the Earth's curvature and its rotation. A flat Earth model would undermine this scientific understanding, potentially impacting the survival of migratory species. Is climate misinterpretation. Flat Earth perspective. Climate models and atmospheric circulation patterns are based on the spherical shape of the Earth. Embracing a flat Earth would lead to misinterpretations of climate dynamics, affecting weather predictions and climate change assessments. Reality. Scientific models of climate change rely on the Earth's curvature and its orientation in space. Rejecting this could result in inaccurate climate predictions, hindering our ability to address and adapt to environmental changes. 4 misguided conservation efforts. Flat Earth perspective. Conservation efforts, including habitat preservation and restoration, are grounded in scientific understandings that assume a spherical Earth. Disregarding this would lead to misguided conservation strategies, potentially harming ecosystems. Reality. Effective conservation requires a comprehensive understanding of ecosystems, biodiversity, and the interconnectedness of species. Embracing a flat Earth model would undermine these foundations, compromising the effectiveness of conservation initiatives. The impact on agriculture. Flat Earth perspective. Agriculture relies on accurate knowledge of seasons, sunlight exposure, and climate patterns. A flat Earth model could disrupt agricultural practices, leading to incorrect planting times and crop management strategies. Reality. The agricultural calendar and practices are based on the Earth's axial tilt and its orbit around the Sun. Rejecting these astronomical principles could have detrimental effects on crop yields and food production. In summary, the acceptance of the flat Earth theory would not only challenge established scientific principles, but also have severe consequences for the understanding and management of ecosystems, wildlife, and agriculture. The rejection of a spherical Earth model would undermine the foundations of modern biology, ecology, and environmental science, impeding our ability to address critical challenges in biodiversity conservation and sustainable resource management. In conclusion, our journey into the flat Earth theory has unveiled intriguing challenges and unanswered questions. The widely accepted spherical Earth model continues to stand strong against these complexities, providing a coherent understanding of our world. We appreciate your engagement and curiosity. Don't hesitate to subscribe for more captivating discussions. And if you found this exploration thought-provoking, show your support by hitting the like button. Stay tuned for more content exploring the wonders of science and our perception of the Earth. Thank you for joining us on the Green Podcast channel.